Hey guys, Dr. Brown here, and tonight we have the integral of 1 over 1 plus sine theta plus cosine theta d theta. Okay, what to do with this one? I would encourage you, look at the problem. You may want to just turn the video off and go noodle around on that for a while. And then when you think you have it, come back and we'll be here. All right, I'm going to assume you've left, you've tried the problem. Now let's get after it. When I looked at it, there was a half angle formula that came to my mind that deals with half angle formulas like theta over 2, and it has cosine of theta on the right hand side of that equation. For example, it says cosine theta over 2 equals the square root of 1 plus cosine theta over 2. So if I square this thing, cosine squared theta over 2, it equals, square root sign obviously is gone, 1 plus cosine theta over 2. Now if I multiply both sides by 2, I end up with 2 cosine squared theta over 2 equals 1 plus cosine theta. So if I subtract 1 from both sides, it equals cosine theta. So that gives me a half angle formula where I can come up with what cosine theta is. So having said that, I let u equal tangent theta over 2. So I'm going to let this angle be theta over 2. So that would be u over 1. This side would be 1 squared plus u squared, the square root of that. Okay, now we have a d theta here. Let's go ahead and get du equals, we'll have an outside function and an inside function. You know the chain rule. Take the derivative of the outside function, which is tangent of some angle. What is the derivative of tangent of some angle? Secant squared of some angle, which in this case is theta over 2. Now the derivative of 1/2 theta, which is what I have here, which is the derivative of the inside function, would be 1/2 d theta. That's the chain rule. Now I need to solve for d theta. Multiply both sides by 2, divide by secant squared, theta over 2, du, and that equals d theta. But 1 over secant squared is cosine, so I have 2 cosine squared theta over 2 du equals d theta. Now I have a half angle formula or half angle triangle, so cosine would be 1, the adjacent side, over the hypotenuse. So I have 2 times 1 over the square root of 1 plus u squared squared du equals d theta. So if I square this thing, the radical sign drops off. So I have 2 over 1 plus u squared du equals d theta. All right. What else do we need here? We need cosine. We need to solve for this in terms of theta. In terms of u, excuse me. I have 2 cosine squared theta over 2 minus 1. So we just had 2 cosine squared, which would be 2 over 1 plus u squared. 1 plus u squared. That equals cosine theta. minus 1 equals cosine theta. Well, 1, I'm going to let the 1 get a common denominator here. Let me scoot that over. 2 over 1 plus u squared minus the 1. And I'm going to let 1 be 1 plus u squared over 1 plus u squared. So if I distribute the negative to the inside, 2 minus 1 is 1 minus u squared over 1 plus u squared equals cosine theta. So now I have, as a function of u, this term. What else do we know about this, about cosine? It's the adjacent side over the hypotenuse. So if I let this triangle be theta in that corner, theta is the angle, it's the adjacent, 1 minus u squared, over the hypotenuse, which is 1 plus u squared. So now this side would be 1 plus u squared, my hypotenuse squared, minus this leg, the adjacent leg, 1 minus u squared squared. If you FOIL that out, you end up with the square root of 4u squared, which is 2u. So the length of this side is 2u. So sine of theta would be the opposite over hypotenuse. So let's fill in the blanks here. I have 1 over 1 plus sine theta, which is 2u over 1 plus u squared, plus cosine theta, which is 1 minus u squared over 1 plus u squared. So we've replaced everything except d theta, and d theta is 2 over 1 plus u squared du. All right, let me move this integral sign over. You'll notice I have a common denominator here, 1 plus u squared, 1 plus u squared, and I have the number 1. If I make that 1 plus u squared over 1 plus u squared, hey, everything is over 1 plus u squared. This one cancels. So I'm left with 2 du over, I have 1 plus u squared plus 1, so I have 2. 1 plus 1 is 2. Positive u squared minus u squared, those cancel. So I'm left with 2 plus 2u. So I can factor the 2 out. So now I have the integral of du over 1 plus u. So what is that? It's the derivative of the function over the function. So if I take the derivative of this, I get du. So this becomes a natural log of 1 plus u, which is a natural log of 1 plus u, which was tangent theta over 2. That looks terrible. Tangent of theta over 2 plus c. And that, my friend, is the integral of 1 over 1 plus sine theta plus cosine theta, integrated with respect to theta. It's a unique problem. I don't use half-angle formulas very often, but that one really came in there. So it worked out pretty well. All right, so I guess in this case, this was the big no, just so I would encourage you, have a cheat sheet of your various trig formulas. I have one that I keep in my phone, actually. And I refer to that from time to time. And this was one of those times. All right, why are we doing this? Together, we're trying to build a better tomorrow through math. Keep studying, and we'll talk to you next time. Thanks.